Hey guys, how's everything going? Let's take a look at number 73, set matrix zeros. We're given an element matrix. If an element is 0, set its entire row and column to 0. Do it in place. Okay. Input this, output this, yeah, update this column and update this row. Update this column, this row, this column. Yeah. So the solution seems pretty straightforward. Traverse all the zeros, keep track of the calls and rows that should be set to 0. Then update the zeros after traversal. Right? It's super simple. Let's say we can use how to say, we can use a set, right, to keep track of which row and columns they need to update. So const a cos of 0, you set const rows of 0, new set. Okay, now let's traverse through all the cells of the matrix. We can use for each, right? For each is much better. Matrix for each row index and each row for each column index. If oh no, this row, this item, this is row, this is column. Oh, ij, it's just ij. If item is 0, we add I cos. A column should be j, right? Okay, j. Rows at I. And then update the zeros. It would be, okay, this time I need to use for I smaller than matrix length for let j equals 0. If my bad. We should first update the rows and then update the columns, right? So this is the rows, and if rows of 0, we don't need to check. We can just update the rows in the columns, okay? But I forgot the set method. What is it? What is it? It's a add. Okay. A values, right? Why there is no set iterator? We can use that for each, right? For let value of I think this syntax is that. Okay, so for let a row of rows of 0 values, we should just set the row. Okay, we need to do it in place. We can just set the row, but let's just say for let j equals 0, j is smaller than. This is the row. J should be matrix. Oh yeah, J row length J plus plus. We update matrix row J equals 0. And then we can update the columns. We do the same. Matrix for J I we can say we should be I and column. We don't do return nothing, so we keep track of the columns and rows, which it should be set to 0, and then finally we set them. It's pretty straightforward. Let's run the code. We're accepted. Let's submit. We are accepted, but we are super slow. First, the traversal. Let's say the time. First, every item will be traversed for once to generate the codes of 0 and rows of 0, right? So that would be O mn plus. We need to update them again. We do it every row, update them, and then for every columns. The worst case, all of these zeros. Then we need to do them again. So that would be like 1 again and then again, right? So the space O m plus n. We keep the track of the columns and keep track of the rows. There's a follow-up here. We actually did the simple improvement using extra space. The basic OM space is we can create another matrix to keep track of whether they should do it, they should keep track, they should update or not. Actually, that would be better than this. For the worst case, that solution will be better than this, right? We use extra space, but we will only do that for once. Here, we do it for twice. So that's kind of a time and space swapping. And the third one is, could I devise a constant space solution that without these columns and rows? Yeah, let's try to do that. Actually, we can. Let's take a look one more time at our example. We traverse through all the items, 1, 1, 1, do nothing, 1, 0. When we meet 0, we can actually start swapping all the setting the zeros, right? We just go to 4 directions, 1, 0, because that's the end of the number. There's no more numbers in direction. Okay, 0, 0, 0, 0, and it's done. For this case, okay, we start with this 0. There's no numbers above. We can go right. So this is not 0. Update it, and go to this 0. We made a new 0. We start first checking this 0 again. No numbers above, no numbers right. So we go down 0, 0, and stop. And for this 0, go back 0, and we have checked that number, so we should stop and then continue 0, 0, 0, and it's done. So actually, this kind of, we can use a recursion, right? I like to call it a walker. It's like I wrote some programs about that, creating like what is that, a visitor, yeah, visitor. Just continue walking through the net or the matrix or the trees and do what it should do. In our problems here is that we just keep walking. If we met a 0, we update it, and it is already 0, right? We update it and go to 4 directions and continue. If we met a new 0, we do that again. The one problem is that when I meet a 0, how can I know that it is the original 0 or it is 0 I set it? Like I've changed these two into 0, but when I met this new 0, I will check again for this direction, right? And it would make a new 0. So I need to know that it is a real 0 or a new 0. So we don't have we must not use extra space. So what I'm consider of is that I will change it to some numbers that is not numbers. What about undefined? So when I met a 0, I first change them all to undefined. So undefined, 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 and then we find a 0, change to undefined, and go to the 4 directions of this new 0, right? So after all doing this, they will all change to the undefined, and I will go to one more round of traversal and change all the undefined into 0. But what if we meet a new undefined, like undefined, 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 and method 0, and for this direction he will check the undefined. When I meet an undefined, it means that the number here must, if it is originally a 0, it must be checked, right? It's undefined. But if it's originally not 0, it is already changed undefined. So we just ignore it. We can continue. So we're just continuing the next number on the same direction. So for this visit method, there will be the coordinate and the direction. Direction, as we did before, we can use a vector with a array of two items to work as a direction, right? Okay, so let's start. The first thing is that we need to traverse through all the items, right? Okay, we copy this one. If item is 0, we update it to undefined. And then we will walk. This is the origin ij, and the direction. We can say the direction is, the first one is to the right, and then to the bottom, then to the left, and then up. And after we walk them all, when the walk is done, we can do it again, right? For each row, if item is undefined, we set it to 0, and it should work. Now let's create the walk method. ij direction. When walk is called, the origin is already set to undefined, so we just check the next one, right? So the next next j would be I plus direction 0, j plus direction 1. This is a new coordinate. if it is within the range 0 and smaller than matrix.length and next j 0 and okay, if it is within the board, within the matrix, let's check the value. If matrix next I next j, if it's a 0, if it's a new 0, we set it to undefined and walk again from this origin, right? So it will be next I, next I, next I, next I. This would be next j, next j. Yeah. Else for the other case, if it's undefined, we can go continue to the next one, right? Let's say if it's undefined, we just continue doing it for the next cell, next coordinate. If it is not undefined and not 0, I'll say we need to set it to undefined and walk, right? Yeah, this should work. Let's try run the code. The time? Unexpected token at 82. 82 is for each maybe something wrong here. This one, this is the if. Oh, made a mistake here. Yeah, I think this is what work. Submit the time. First, all the digits are, all the cells are traversed, so it's OMN. And then we walk, right? And then finally we will update this, so it will be again MN plus the walk. So what's the time complexity for walking here? Absolutely, according to our submission, these methods will run faster. But I think that's because of the test cases, right? For the worst case, like all zeros, our solution will walk straight to the right, and then again, and then again, and then again. Plus the recursion. For the worst case, yeah. Worst time, all zeros, right? For all zeros, okay, 0, update, 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 here, 0, and then update, update, and 0, update, update, 0, and update here. Okay, so the actually here done. Now again, done, done, done. So actually, worst time, all the numbers will be checked for 4 times from 4 directions. So it will be 4 times for each cell. It will be, I think it's generally plus 4 times O mn. It will be 5 O mn. But this is for the worst case, right? But the best case will be much simpler. So if, for example, there will be only 1 0 like this, best case there's we will just traverse for one time and one time. Actually, this much faster than our previous this solution. So that's actually there's no absolutely fast or slow, but according to our submissions, these solutions is much better because of the test cases, right? The test cases are not all worst cases. Generally, this will be better, I think, because not only we improved the time complexity for the general cases, but also we have avoided using extra space. We use nothing, right? It's constant. Cool. Let's submit. So a walk like a visitor. I like these kind of things. But I tried it little. I tried something before, but that's not slower than this one. Again, I would try using the for loop for the for each. Maybe for is faster than the for each, right? I don't know. Smoother than matrix then. But for a real whiteboard interview, I think there's no need to discuss about the language spec of which for is faster or for each faster. Actually, I don't know. Okay, and now we will copy it again. If it's undefined, we update to 0 with this 4. Let's try to submit again. It's the same. Okay, wow. Even my memory is wrong. Okay, so that's all for this problem. Hope it helps. Thanks for watching my video. See you next time. Bye bye.